Hello, can you hear me?
I can hear you.
Yeah, cool, cool. So, glad to have you here. May I have your name?
My name is Robert.
Okay, cool. So this is our maybe monthly or bi-monthly the community the check the to share all the progress of the Moonbit and our direction in the coming months. So I'm very happy to have you here and yeah, so yeah, so I think the biggest thing we have like in the last few months, I think in the last month is we unleashed our native backend. Uh, Currently it's the using the so currently it's using the ARC called the automatic reference counting for the garbage collection and compared to the subset of C program. But it's also on our roadmap to support the LVM backend. And pretty soon, I think we will land the LVM backend in probably by the end of this year together, maybe sometime later. And also we are also adding some new backend, not just the native for native backend. We are going plan to add multiple backend. So this backend, native backend is for mostly for the edge device like the MCU, for the like tiny hardware. That's the mostly the target scenario. And also we are planning to add the uh, like tracing garbage collector and the LVM backend for the server side. So Moomi is like Moomi has a lot of backends. We have like the 4 or 5 backends, but they are for the user, from user point of view, they will only be provided with a Moomi SDK. So they don't need to care about the what backend they use. For example, when you are doing the Arduino, like the hardware encoding, uh, programming will provide you the hardware MoonBit SDK. So you don't need to care about the backend what you are doing. And then we do a self side, like the web server will give you our LVM backend and the tracing capture collector for the most max performance. That's our plan. Feel free to have ask me if you have any question. So this is our uh, the big news for the native backend. And one thing surprised me is when we do the backend, do the push mark before the release of our native backend. Actually, the performance is pretty good. So, like for the numeric computation, the Umbi native backend actually is much faster than most existing like the garbage collector language like Java. We didn't benchmark with the OCaml because or other like the or but I think where the performance actually should be better than the OCaml or other garbage collecting languages, which is to our surprise. And for the like the memory behavior, I think it's reasonable, close to the overall performance is close to the Kotlin and Swift, which is and overall, I think the performance is beyond our expectation. This is for our native backend. Also for the other direction we're betting on is AI. It's for the AI code generation. So pretty soon we have our own MoonBit IDE. So the MoonBit IDE will be like the cursor, something like cursor, but it's dedicated for the MoonBit language. So it's not like the it's unlike cursor, which is a language agnostic IDE. But for MoonBit AI, it will be almost hey Logan. Uh, cool. Uh, so it's yeah. So we have the can you hear me? The hey Logan, you say hi? Oh, that was still the
I can still hear you. I
oh,
don't know if he's
cool.
connected or not yet. Yeah.
Oh, cool. So for the new audience, I want to share you with the quick brief of our big news in the last month is we have like the native backend. Yeah, the native backend. So this is our first. We couldn't have multiple native backends. Our first native backend is using our own automatic reference counting, but it's only precious garbage collector and to compile to C, and then generate the native code. So the first native backend is primarily targeted to the MCU, for the hardware, and we'll pretty soon to have our another native backend, which is the LLVM-based native backend for the server side. Cool, cool. We have our old friends, the Jim. Uh, cool. Yeah. Jim, can you hear? Can you hear me? Uh, Cool. So yeah, so yeah, great. So we have all our friends. Yeah. So I want to give you a quick brief overview of what we did in the last month. Is the big thing we have in the last month, we released our native backend, and for the first native backend actually is targeted to the MCU device. So we go to the pick the route to using our own automatic reference counting, which is based on a purchase garbage collector from academia, and we generate a subset of C code, which can be compiled to the almost most hardware. So this is for the MCU device because it's very C-friendly. We'll soon provide our own MoonBit SDK, like the Arduino device if we head off. So we can use the MoonBit to do the program the microcontroller, and that's the primary target scenario. And soon we also have the LVM backend. I think in a few months to LVM backend for the self-side programming. So, and we also develop our own the tracing garbage collector for the self-side programming. So even for native backends, we have different choice. But what we want to present to the MoonBit users is like you only need to know the MoonBit SDK to develop to develop applications. So what backend you want to use actually is the should be hidden from the user. So they only do the movie programming. That's our main vision for our native backends. If you have any question, feel free to interrupt me to ask questions. So this is the one big side, I think, because we also support like the RISC-V, a lot of the hardware. So we actually spark a lot of interest from the hardware vendors. This is one thing we want to share with you. The other thing we want to share is AI. So we will have our own MoonBit IDE soon available to users. Uh, so it's like the cursor, but it's unlike cursor, which is a hey Fox, welcome. So so the second part is the MoonBit AI. So MoonBit AI is for the we put our own ID, but the whole stack will be like the MoonBit focused because we know the MoonBit first, so, the best, right? So we want to do the so we will ship a purely MoonBit IDE to the user maybe next month, I think, if everything goes well. And the cool thing we have the MoonBit AI is we can do a lot of things when we're doing a language specific way. Because, for example, I'll give you one scenario is when you do the AI coding, like Copilot, right? So you have to do because the large language model is not tied to a specific programming language. So when you have like the 100 warnings, you have to use the AI to fix your problem one by one, because then you ask the large language model to generate the generate output, and you do the human review the code, and then if everything goes well, you click accept button, and then accept the AI generate code. But this is pretty slow because you still have a lot of human intervention in the loop, and you're going to get like a 20% maybe performance boost. It's not a lot. Basically, if we go the MoonBit approach, we can do this in a parallel, in concurrent style. Our own IDE is adapted to the AI style. So we provide our internal API to provide. So we can ask the AI to generate 100 patches for for the problematic code, and then for each patch, we provide some isolation for the AI to give the AI the diagnostic. It's purely each patch is isolated. Then the patch will be validated using our own static analysis, and then go through our own test engine. So we think we can give you a productivity of the parallelized productive boost, unlike the Copilot approach. Copilot only give you the productive boost for like the 20%, right? If we do the highly parallelized AI agent approach, and we plus our own static analysis tools, we can give you like the 20% times n. N is the parallelism, give you a very good productive boost. So yeah, so watch out. So we will have our own ID, AI-based ID soon for the user. And oh, cool. I have one question. Will the AI work with with other ID as well as the only the MoonBit? So yes, so we'll do our best to make the our AI plugin to work with the VS Code. So it's our main target audience. But for some functionality, like which is it's very hard to do in the VS Code because they don't provide you some UI stuff. So it's so Microsoft doesn't give you the ability freedom to do some UI. For those parts, it's only available in MoonBit ID. But if once the VS Code, the code, once the VS Code give you us the API to do some UI, we'll give you we'll catch up. So yes, so our AI based ID will work for a large part. We work with the VS Code, but for some parts maybe it's missing. But our MoonBit ID will be completely free. We never plan to charge any user for the ID. So it's not our business model to charge the user for the tool training for ID. So it's not our interest. We will give all MoonBit users the best experience when program MoonBit. So it's not our we don't plan to make any intentional difference. That's the. But for other ID, maybe the Emacs, Vim, we have no bandwidth to supply. So does this answer your question?
Yes, thank you.
Okay, cool. So yeah, but of course we choose the very difficult approach to do this. So we work slower than the cursor or Copilot because MoonBit doesn't have a lot of the training data. That's the problem. But I think this is the right approach. It takes more time, but it's a hey Lucas, welcome. So our approach, I believe, is it's more robust, but it's a bit slower. It's a bit slower. But I think great things takes time. Great stuff takes some time, so we can wait. And I think the MoonBit AI approach is more future proof in my opinion. So yes, so this is another part I want to share with you. The last part I think is also exciting plan we want to share with you is we plan to open source our MoonBit, the Wasm GC compiler. So this is our most production ready and most polished and most competitive backend because yes. So we also have one slight news to share with you. Soon, I think in November 6th, the Chrome will have the Wasm. We have one proposal called the JS built-in stream proposal landed, and which is available to every Chrome user since next month. I think it's November 6th. In that case, this is quite a big proposal. So the JS built-in stream means you have zero cost FFI when you pass string around. This is huge because then in that case, MoonBit stream will be free available to the JavaScript users, and we also can call the regex expression API. A lot of API will be much easier to communicate from the Wasm side and JavaScript side. So I think by that point, actually MoonBit will have a large performance gain of the JavaScript applications because previously when we say MoonBit is fast, right? Wasm is fast, but it's not true because there's a lot of overhead for the FFI. I think the JS built-in stream is a big proposal for us to realize the performance benefit. And the other thing is we also have some advantage over Rust, because the Rust is still like compare the Rust to a linear memory. So you don't have a good story when we want to do the interoperation between the Rust and JavaScript. But it's not the case for the MoonBit. We can reuse the full garbage collector, which is available in the browser, and we can reduce the easy FFI between the MoonBit string and JavaScript string. So I believe MoonBit will be a better choice for the web programmers to pick back on the Watson power. So that's exciting news. We will write a blog to introduce the MoonBit support for the JS built-in stream. So this I think it's quite exciting. And thank you, Robert. So let me come back to the open source plan. So we plan to open source our, as I said, the Watson GC backend later in next month. I think probably November 22nd. Yeah, so but I also want to be honest, because the MoonBit team is moving very, very fast. So we are not ready to take contributions back from the external contributors. So because the communication and the code review takes a lot of time. So it will be, the source code will be available, but we are happy to answer questions. And if you do have some patches, we are happy to accept maybe like the Linux kernel mode is send us a patch of the mailing list, and we are happy to review and accept. Actually, I want to hear you if you have any suggestions for us. What do you think? If this is our current plan, I'm very happy if you have any question, and I want to. Sorry for my English is not my native language. So if you have any misunderstanding, I'm also happy to clarify what I said about the open source plan. Yeah, so to summary, so we are going to we're planning to open source our MoonBit Watson GC backend, but because the current stage we are moving very fast, and the code review takes a lot of time. So at this stage, it's only like for public access. We are not yet ready for the taking contributions from external contributors. So this is our plan for the MoonBit. Yeah. So do you guys have any question about the open source plan? I'm very happy to hear what you think. Cool. Okay. Thank you, Jim. Yeah. So yeah, another cool stuff we actually I want to share with you is the let me share my screen. So our Try Playground actually is not advertised yet. It's now accept the our Try Playground now can accept the GitHub. Actually, you can go to the try.moonbit.com. Previously it's purely client side, right? So our now client ID can accept something, for example, like the MoonBit X. So we can load in the X code base in our client side the ID, or it takes some time. But once it landed, it should be pretty fast. Uh, oh yeah, that demo is yeah, anyway, but the idea it doesn't work, but we're going to fix that. But the idea is all online IDE actually can load your GitHub code base, and then you can make your change. You can make change. Yeah, let me dash out. Yes, so our online ID probably in the next week we is able to load your code base, and you do the change, and you push back to your GitHub. So for the lightweight, I believe it will be scaled to for a medium-sized code base, like the 10,000 line code. Then you can do all stuff in the client side. But the cool thing with compared with other cloud-based IDs, this is purely local. So there's no only for the only for the file storage, only for set storage. When you want to sync your code base, then you will be synchronized. For other parts, your IDE is purely local, so you can still get your instant feedback from the analyzer. So this is something I want to share with you. Okay, for the people to wrap up. So to wrap up for the people who come late, I want to to summarize. So there are three big things I want to share with you. One is that we have the native backend. We have native backend, and it's not the end of story. The first native backend is for the MCU for the edge device, but very soon we will also have to like the LVM sub backend and our tracing garbage collector. Also, I forgot to mention. So we are also going to plan to contribute back to the open source the WebServer runtime like the Walmart. So we plan to add a tracing garbage collector for the Walmart. So Walmart has like which is one of the most used WebServer runtime, but it doesn't have the very good garbage collector support. So it's still use the stop the world garbage collector support. So we're planning to contribute back to the Walmart runtime. So to summarize, the native backend will have like the C backend for the edge device and the LVM backend for the high performance server side. And plus, we're also planning to give back to the Walmart for our tracing garbage collector. And AI is another scenario I'm very excited. So soon we have our AI complete AI ID like Cursor, which is a fork of the VS Code with our own programming language enhanced intelligence back to the. And one thing I'm pretty excited is the concurrency. We can add the AI. We can use the AI in a more parallel style compared with the traditional Copilot. The last part is the open source plan. Yeah, I'm very open source plan. So we are going to open source the MoonBit, the most polished backend, WSM-GC backend to the user, so people can comment review. But at this stage, it's only for the we are not ready to take the external contribution, so we will only make it publicly available, but not for the public open development. Another thing I want to share with you is the roadmap. So the Moon language is pretty stable at this stage. So starting from December, we plan to add the async support. That's the last missing part from MoonBit language. So async is very hard to get correct in one step. So we maybe spend like half a year, or maybe even longer to make sure our async is good. So yeah, that's the thing I want to share with you. And feel free to ask me if I have any question. And I'm very happy to take any external feedback on any question. Yeah. Yeah. So my part is yeah, it's something I want to, is all I want to share with you. Do you guys have any question? Yeah, I will be happy to answer. Cool. Okay. Yeah. So actually, another thing I want to share with you is actually the MoonBit user is actually growing pretty fast in the last 1 or 2 months. So before the August, I think before the July or August, we only have like 3,000 installed users, like the 3,000 installed users. But in the last month, we grew to the 10 times. Yeah, it's true. We have 10 times more users in just single month. So we have like close to 20,000 installed users at this time. So actually, this is a lot for language which is only 2 years old, within 2 years old. But we have more ambitious goals. So our in the beginning of this year, we plan to have like the 10,000 users by the end of the year. But we already surpassed our original goal. So now we have 20,000 installed users at this time. We plan to have we plan to have like the 100,000 users by the end of the next year, which is by the end of 2025. Then hopefully we can get 1 million users by the end of the 2026. So although we are very young, but I'm very optimistic. So we actually were steady realized try to we're steady moving towards the goal. Uh, yeah, I think we will. I think there's a large chance we can realize our goal. I'm very excited about the future of the movie, even though the movie is still pretty young. Yeah, it's cool. That's pretty much all I want to share with you. Feel free to ask any questions if you have any, either online or through the Discord or on the Twitter. Anyway, okay, thank you, Jim. Yeah, so if no any question, I think we are on time. We can, uh, yeah. So this update will be, we are on time. We can finish it here. All right. Thank you. Have a good day. Yeah. Thank you, Robert. Have a good day. Bye bye. Bye bye.